Math 117 and welcome to your second instructional video of Unit 1. This is about solving problems with math, which is a little bit about word problems, which I know as soon as I said that, a lot of you just X'd right out of the video. You're like, I'm out of here, I can't do it, boo. Don't worry, guys. In this video, I'm going to go over some strategies for solving word problems that will hopefully make it a little bit easier and give you a couple of the examples that, in my experience, students struggle the most with in the homework section here. So I want to give you these examples. We're going to work through them together, and then I'm going to ask you to try the homework on this section, on the word problems. And of course, as always, if you are having any difficulty with the homework problems, please go ahead and post them to the forums and get some feedback from your classmates and get some feedback from me, myself. You can also reach out to me in my office hours, in person or online, or just shoot me an email and I'll do my best to help. So here we have the problem-solving strategies that I'm going to present you with. So George Polya was a Hungarian-American mathematician, and he contributed to the development of combinatorics, number theory, numerical analysis, and probability. He wrote 5 books on how to solve math problems, and he gave these following steps for how you can solve problems with math. So he said, 1, you have to understand the problem. 2, you have to devise a plan. 3, you carry out the plan. And 4, you look back and reflect. And you repeat this process as many times as you need to until you get the right answer. So let's go through this process with an example problem. So let's say you want to know, how many times does your heart beat in a year? So the first part of this problem is just to understand it, right? What are you trying to find? What do you need to know? This one is pretty straightforward. You want to find the number of heartbeats in a year. Sounds okay so far, right? But how are we going to do that? So let's talk about devising a plan in step 2. Obviously, I don't want to sit here for a year and count all my heartbeats. 1, that's not possible. And 2, it doesn't sound like my idea of a good time just to count my heartbeat all day. In fact, I don't want to count my heartbeat for that long at all. So what I think is a better idea is I can figure out the number of heartbeats in 1 minute, and then I can manipulate that quantity until I figure out how many that would be in a year. So here is me carrying out that plan. So suppose we have 80 beats in 1 minute. If you watch the last video on unit rates, you'll recognize that this is a unit rate. For every 1 minute, I have 80 beats. The next thing I got to do is I have to convert that up to a year. So I'm going to use these conversion factors that you may or may not recognize. So you know, okay, I know that I have 60 minutes in 1 hour, 24 hours in 1 day, 365 days in 1 year. And I've set up this dimensional analysis problem just like we did in the last video so that I can cancel my units. Notice minutes and minutes will cancel. Hour and hours will cancel, day and day will cancel, and the only units that I'm going to have left at the end of this problem are beats per year. So I want to know how many times my heart beats in a year, so I want a beats per year figure. So all of those units cancel out. Well, how did I actually do this calculation? Here's what we do. Let's do that in black so you can see better. 80 times 60 times 24 times 365 and divide that by 1 times 1 times 1 times 1. Great. I love the denominator of this problem, don't you? So we're going to have per 1 year is going to be in the denominator. And then in the numerator, we're going to take 80 times 60 times 24 times 365. And that gives us the figure 42048,000. There we are. So that's how many times our heart beats in a year. So a lot of students are done at this point. I got a number. Numbers mean answers. Life is good. Let's move on. But you do want to take a second to evaluate this and think, does this make sense? Kind of reflect on that answer. So let's think about this answer. I think the math checks out, right? Which means it has to be a decent estimate. But what if somebody works out more or less? What if they exercise a lot? Would they have more heartbeats because they get their heart rate up? Would they have less heartbeats in a minute because their resting heart rate is lower? I don't know. Does it matter if it's a child or an adult, right? Why would I be interested in this figure anyway? Why would somebody be looking up in this information, right? When I say the step 4 is look back and reflect, that means just think about all the questions that you have about your decision-making process, your problem-solving process, and yeah, all of the questions you have about whether or not this is actually important or does this relate to anything that you know in real life. In this case, I don't personally have an application for this. I don't know what this might be used for. But somebody might know. Maybe you're an Apple Watch developer and you need to know so that you can set up something about the fitness tracker. I don't know. Here's an example from the homework that I'm going to walk you through. I really like this example and I'll tell you why. This is very similar to an actual problem I had to solve. Okay, so let me read the example. When ibuprofen is given for fever to children 6 months of age up to 2 years, the usual dose is 5 milligrams per kilogram of body weight when the fever is under 102.5 degrees Fahrenheit. So how much medicine would be the usual dose for an 18-month-old weighing 23 pounds? I told you guys, this is exactly what happened to me. I had to figure this out. But I had to figure this out at 2 a.m. while my oldest child barfed all over my bed. So she, poor thing, was about 3 at the time. She's 5 as the recording of this video. And she was throwing up everywhere. So I had to figure out this in the middle of the night. All right. So I know the child's weight in pounds and their age. I know the dose per kilogram of body weight. And I need to know the dose for this particular child. So that's the problem I have. I'm just setting up the stuff that I know and that I need to know so that I can understand the problem. In step 2, I have to figure out how to put those things together and to make a plan. So I think what would work here, since I know the child's weight in pounds and their age, and I know their dose per kilogram, if I can change pounds into kilograms, right? So if I can convert the weight of the child from pounds to kilograms, that's going to get me somewhere. And then once I know the child's weight in kilograms, I can use that information. I can use the weight in kilograms and the dose of 5 milligrams per kilogram to figure out the right dosage. Okay, so notice I haven't done any calculations yet. I just am figuring out what I'm going to try first. So to do this plan, I'm going to need to know a few things, right? Like I'm going to need to know the conversion factor, right? How many kilograms are in 1 pound? That's what I'm going to need to know. So let's give it a try. So the first thing I need to do is to convert the weights. And so off to Google I go. So here it turns out that I have a conversion factor. 1 kilogram is about 2.2 pounds. And so I'm using dimensional analysis here. So I know the weight of the child is 23 pounds. You can look at this as over an invisible denominator of 1 here. And I know that 1 kilogram is about 2.2 pounds. So here pounds and pounds will cancel. And I know that for every kilogram of body weight, I need 5 milligrams of ibuprofen. So then I'll go ahead and set that up here. For every 5 milligrams, I will use for every 5 milligrams of medicine, 1 kilogram of body weight. And now I can cancel kilogram and kilogram. So at the end of this process, I will be left with milligrams that I need to give my child. Okay, so let's go ahead and do this calculation. I will show you how this works. Here's a cool trick that you can do with your calculator. All right, so I want you to watch this. This is going to be helpful for doing fractions, because if you look at how we want to set this fraction up, we want this to be 23 times 1 times 5, all divided by 2.2 times 1. Here's something you can do to help you work on your calculator skills. So I want you to touch in your TI 84 or 83, I want you to touch alpha, y equals. And you see that number 1 that's highlighted in pink, it says n over d. Go ahead and hit enter. And that's going to give you a fraction bar. So you can do 23 times 1 times 5, and then hit the down arrow on your pad. 2.2 times 1. What's nice about this is that it's going to look exactly like what you've written on the page, and it's going to preserve your order of operations so that you don't have any calculation errors. And we're going to use this throughout the semester to make things a little bit easier for you. So here is what we get. 57.272727 repeating on forever. So I want to round my answer to the nearest milligram. So about 52 milligrams of ibuprofen is what you're going to use to help your child. Okay. I really hope that if you ever have to solve this problem, that your kids do not spit it out. My kids spit out medicine, every kind of medicine when they're babies. When they're old enough for me to explain, they'll actually take medicine about 40% of the time, which is good. But when they were little, they would just spit it out immediately. So I'd be like, well, I was supposed to give you 52 milligrams. I think you got it. We'll see. All right. So let's look back and reflect on that problem. Does that answer make sense? Do you think 52 milligrams is a reasonable amount? Are my calculations reasonable? One thing you might wonder if you looked this up on Google, why did I use a conversion factor instead of one of the calculators available on Google? There are calculators available on Google. In fact, you can even Google or ask Siri how many kilograms per pound and things like that. So why did I use a conversion factor instead? These are some questions that you might be curious about. Let's try another homework example. All right. So here's one of the ones at the homework that you'll see. You'll recognize it as soon as you open it up. It says, I was at the store and I saw 2 sizes of avocado being sold. The regular size sold for 94 cents each. The larger avocado is just under twice the volume as the small avocado. So for what prices would the larger avocado be a better deal? Save some money here. All right, so we have to understand the problem. The problem is that I'm a millennial. I want to buy a house one day. I cannot be wasting money on avocado toast, okay? I need to know, is it smarter to buy 1 large avocado or 2 small ones? Okay, I want to know. I want to save myself some money. So I have to figure out a plan. What I'm going to do is figure out the cost of the 2 small avocados. And then I'm going to compare that to the cost of the large avocado. So if 2 small avocados are cheaper and they're about the same volume, then it's better to buy the 2 small avocados. We're assuming here they're all perfectly ripe, okay? And they're delicious and ready to roll. So let's go ahead and see this, if this works out. I'm carrying out the plan. So I know that I have 2 avocados for 94 cents each, which is about $1.88. So if the large avocado costs less than $1.88, I should buy it. I'm going to save the difference, and then all of those little pennies will add up and somehow turn into $1 million for me to buy a house in Westchester County. Dream on. But I will save a couple of pennies, and I'm a penny pincher. You should be too. So let's look back and reflect on that problem solving. Does it make sense? Yeah, sure. Whatever's going to cost less, if they're about the same size, it's going to work. Is this like a real world problem? Absolutely. I can see myself at the grocery store always trying to figure out what's a cheaper deal, what costs more, what costs less. This is a real world, everyday kind of math situation. So this is how I'm going to advise you to try some of the problems in this section. All right, you are now ready to take a try at the problems in this section, which are, I'll warn you in advance, all word problems. So you have a bunch of word problems coming up, and I want you to give them a try before you reach out to me. I want you to try these steps. And for every problem, if you come to my office hours or you post it to the message board, I'm going to ask you what you tried. What was your plan that you carried out? And you're going to have some kind of answer for me. All right. I want you to have some kind of attempt. It's okay if your first attempt gets the wrong answer. I just want to see you trying, because that's how you're going to get better. All right. So enjoy these word problems as much as possible. Please don't curse my name too much while you're working on them, because if you know what, if you need help, I'm here for you. All right. I hope you have a good day, my friends.